And we have this length of the member, that is hollow column, that is we'll take it as L. We'll take it as small L, so that is L. Right. So what is given? A hollow steel column of external diameter 150 mm and internal diameter 100 mm. So we'll take this external diameter as D naught. D naught is 150 mm, right? And internal diameter as DI. We'll take DI as what it is given is 100 mm. Then length of the column, that is hollow column, it is how much? Length of the column is how much?
1.2.
Anybody can answer. Yeah, it is 1.2 meter. It is 1.2 meter. So as any problem, you keep all the units in single units. Here and there itself, you just convert this 1.2 meter to mm. So into 1000. So it is 1200 mm, right? Then is subjected to an axial load of 600 kilonewton. So it is subjected to some axial load. So we'll take it as F. So one side is fixed, then other load will be. So load we have taken it as P. So we'll consider it as P only. Axial load of P. The load is P will take. P is equal to how much? Load is
600 kilonewton. 600 kilonewton.
600 kilonewton. That is 600 into 10 to the power of 3 newtons. Then what else is given? The Young's modulus of a material is given. That is modulus for this material used. So we'll take that modulus as capital E. 2, how much? 2 into 210 into 10 to the power of 3. Newton per mm square or megapascal, both are same. Newton per mm square or megapascal. Both the units are same. Full stop. Then they also given the Poisson's ratio. Poisson's ratio, will take that Poisson's ratio as mu. It is given by mu or 1 by small m, both are same. The units. So that is equal to, just consider only mu. No. So that is mu is equal to 0.3. 0.3. So this is the given statement for the problem. You need to find out what they ask you to find. Determine change in length and lateral strain. You need to find change in length, and then it is delta L and lateral strain. Lateral strain. Lateral strain. So these two terms you need to find. Right. So these are the things you need to find. So what is the change from the first problem? If you want to find out the lateral strain, so what is the expression? You know the definition for Poisson's ratio. What is the definition for Poisson's ratio? Poisson's ratio, it is defined as
Lateral
ratio
strain
of
by linear strain.
lateral strain to linear or longitudinal, both are same. Linear strain. So what is this delta L? Delta L is what? It is linear or lateral strain?
Linear.
Change in, yeah, delta L. So as this column is subjected to axial pull, it is subjected to axial pull. So as the pull is done, so along the direction of the axial direction, the elongation takes place. That is called as delta L, deformation. Delta L, that is longitudinal strain. So you first find out this longitudinal strain. Next, use the Poisson's ratio definition. Definition, that is lateral strain to longitudinal strain. You have already found out the you will be finding the longitudinal strain from the previous value, you substitute this longitudinal strain, you will get the lateral strain, right? So now how to find out this delta L, longitudinal strain? So it is similar to last what you have done. So these are the given values. So we'll find out first. First you find the diameter. What is that? Is it visible? First you, what is that cross section here? It is not a solid shaft. It is not a solid column. Solid. It is a halo, right? So how to find out the area for halo? Halo cross section. So since two diameters are here, first you find out the area of the cross section. Area of the cross section, that is equal to, the general expression is what? Pi d square by 4. So if it is a solid shaft, if it is a halo column, if it is halo, then it is given by pi by 4. We have taken d naught, small letter. D naught minus di, right? D naught minus di. What is the expression? D naught square minus di square divided by into, that is pi by 4 into d naught square minus di square. You calculate the area of the cross section first. So after finding the area of the cross section, then it is similar to last problem you have solved. So only the expression that is different is the area of the cross section. So next you just use the general expressions, what all you know, to find the change in length. So in the last class, you have used one expression I have done in a note, right? I had written the note and I had given the expression for change in length. So that expression also you can directly use. So what is that expression for change in length that we have written in note? Change in length in the last class. So that is equal to delta L. That is given by what? Last class you have written, right? So we derived the expression that is in the note I have written. So delta L, it is given by, according to Hooke's law, we have stress is equal to
PL by A.
Yeah, use that expression, and also we use the expression for stress. Stress is equal to force by area. Then we use change in length, strain equation, delta L by L, substituted there, and we got delta L expression as what? P L divided by A, remember? Right? So use this expression for change in length. Yeah, first you see whether I know all the quantities. P is the load, it is given. Load is how much? Is there 600 kilonewton. Length of the column, it is L, it is given 1200 mm. Area you just find out. How much area you will get, you just find out. E is the modulus. Substitute all the units in single unit that it has to be in mm or meters. So we have taken all in mm, find out, you will get change in length. Right? So next, use the Poisson's. So this is what? Change in length is nothing but, or this is linear strain, right? This is nothing but linear strain. Delta L is nothing but linear strain. Linear strain. So use this linear strain. You know the equation for Poisson's ratio, that is mu, is given by ratio of lateral to linear strain. Lateral strain to linear strain. So now you find out what is lateral strain. How much it is, you just find out. It is just a number. So find out the lateral strain. So now you just tell me what is area? Area, how much you got?
1963.49 millimeter square.
The bearer, others. ಬೇರೆ ಯಾರು ಮಾಡಿಲ್ವಾ?
9818.75 millimeter square.
Yeah, that is right. 98.
18.75.
98.
18.75.
0.75 mm square. So this is right. So just noodle. So substitution and miss ಆಗಿರುತ್ತೆ. Next you find out what is delta L. Delta L ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ. Right. So this delta L you'll get how much? How much? Delta L or DL it is. Etc.
36.66.
Where? Should be unit is change in length. Our linear strain is how much? PL by AE. So you'll get something like what? How much? It should be in point something you'll get.
0.3.
Yeah, 0.3.
3666 millimeter.
366, huh?
Yes, sir.
Okay. Then you use the Poisson's ratio equation. So lateral strain is equal to delta L into mu. Mu into delta L, you will get the lateral strain. Delta L into mu, you will get the lateral strain. So longitudinal strain, due to longitudinal strain, there will be increase in length. There will be increase in length. Due to this lateral strain, what happens? This diameter, as the length increases, the diameter reduces. The diameter reduces. So that is the outer diameter. So you may also ask you to find, then ask, find the change in diameter or decrease in diameter. If that is asked, so this lateral strain, after finding this value, we'll get some value. So this lateral strain is equal to, so that is lateral strain will be equal to change in diameter, that is delta D. So basically we will take the outer diameter D naught by initial diameter D naught. So similar to the strain value. What is strain? Change in length to original length. So if it is a lateral strain, so that will be equal to change in diameter to original diameter. So the change in diameter will be the outer. So that you will get it D naught here. So that is delta D naught. So not. You need to find out delta D naught. Illi lateral strain value barutte nimge. If in the problem, some problem, they may ask you to find out delta D naught. The change in or reduction in diameter that can be found after finding the lateral strain. In this problem, it is not asked. If at all it is asked, you can calculate that also. So what is lateral strain? How much? This birth value.
9.15 into 10 raised to minus 5.
Sarina, bere?
0.1098.
So it is just a multiplication. Is sorry the answer? Change in length, it is right. 0.366. So if it is right, just multiply 0.366 into what is that? Mu. Mu is 0.3. How much it is? Lateral strain is just a multiplication. You just do it. I don't know. He'll answer illa now, right?
0.10998.
So lateral strain is 0.10
10998
ಇಷ್ಟೇನಾ ಇಂಟು 10 ಏನಾದ್ರು ಇದೆಯಾ?
ಸರಿ ಲಾಸ್ಟ್
ಇಷ್ಟೇ. So next, this is the value for lateral strain. So if at all it is asked to find out any, as I told, find the change in diameter or reduction in diameter, change in diameter. What is the final diameter of the specimen? You can substitute lateral strain. Lateral strain is equal to change in diameter to original diameter. Only we'll consider outer diameter, so that can be found. Fast. So it is finished. If it is finished, I'll just wipe it off. So we'll move to next topic. So these are the just simple general problems in introduction to stress and strain. So we have solved, we have used all the equations from Hooke's law, general stress equation, Poisson's ratio equation, factor of safety, percentage reduction, percentage elongation, right? So these are all the equations we used. So these are the basic things that has to be carried forward to solve the problems in this subject. So is it finished, right?
Sir,
Agidya?
lateral strain is equal, sir.
ಹೇಳಿ.
Sir, lateral strain ಅಂದ್ರೆ linear strain into mu ಅಲ್ವಾ sir?
ಹೌದು, ಇಲ್ಲಿ ಬರ್ದಿನಲ್ಲ. Lateral mu is given by lateral to linear. So lateral strain will be equal to linear into Poisson's ratio. So that will,
Sir,
that is the
delta L
expression
into
for.
mu ಹಾಕಿದಿರಾ sir ಅಲ್ಲಿ?
Sorry, lateral strain is equal to, sir, ಉಲ್ಟಾ. So this is given by, ಸರಿ ಇದೆಯಲ್ಲ. So delta linear strain is what? Linear strain is delta L. Correct alva? So linear strain is what? Is nothing but delta L. So I have taken delta L in terms of linear strain. So multiplied, you will get the lateral strain. Sorry, ಇದೆಯಲ್ವಾ?
Sir, linear strain ಗೆ delta L by L ಅಂತ ಬರುತ್ತಲ್ವಾ sir?
ಹೌದು.
ಅಲ್ಲಿ ಬರೀ delta L ಆದ್ರೆ ತಪ್ಪಾಗಲ್ವಾ sir?
Linear strain ಗೆ delta L by L ಅಂತ ಬರಲ್ಲ. Strain is given by delta L by L. Strain is, general expression for strain is change in length to original length. So what is that delta L andre? So that delta L is nothing but linear strain. You just look at this sketch. So this is applied with tensile load. ಈಗ ಇದು load apply ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? So it is under strain. So what is the strain induced in this is change in length. So this change in length takes place along which direction? Along the direction of the force. ಈ force direction ಅಲ್ಲಿ increase ಆಗುತ್ತೆ length. So that is nothing but linear strain. So that change in length is delta L. Right? ಅರ್ಥ ಆಯ್ತಾ?
Yes sir.
Okay. Okay, ಆಯ್ತಾ ಇದು? So we'll just move on to next topic. Finish. We'll just wipe it off. So next is, we have a next topic, problems on varying cross section. So iduvarge ಏನು ನೋಡಿದ್ವಿ? We have learnt about, for example, in the previous sketch, it was a even model. For example, ಈ dust ತಗೊಂಡ್ರೆ the cross section, it is continuously same. So if you take a section at any of the plane, the section, if it is a rectangle, throughout it is rectangle. So we solved the problems on these types. Now we will just solve the problems on different sections. So ಇಲ್ಲಿ like some diameter 10 mm ಇರುತ್ತೆ. ಹೋಗ್ತಾ after certain length, the diameter it may be reduced or increased. So if that is the condition, how to solve the problem? So next topic is problems are beams subjected to single load with varying cross section. Members or beams, we take it. So that is members subjected to uniform load or you can take members with varying cross section subjected to uniform load, or members subjected to uniform load with varying cross sections. Varying cross section. So this is the next topic. So that is, we have a different cross-sectional members or bars with varying cross-section in steps. And in simple, if you want to tell, bars with varying cross-section, that can also be taken. Right? Or members subjected to uniform load or uniform constant load. Constant load with varying cross-section. With varying cross-section. So you can take we have a small derivation for this, simple derivation. For example, the problems may be of this type. We have a cross-section So we have stepped bar. So we have a stepped bar of different. So you can take the ends as AB is of different diameter and length. BC is of different diameter and length. CD is of different diameter and length. So, and this bar is subjected to some tensile load P we will take. P is the tensile load acting on the bar. So just take, these are the lengths. L1, L2, L3. L1 is the length of AB, L2 is the length of BC, L3 is the length of CD. And similarly, AB is of diameter, we'll write it as phi, diameter D1, and BC bar is of diameter phi, D2. Then CD is of diameter D3. Okay, this is the stepped bar of different cross section. Right, it is of same cylindrical. You just imagine it may be of cylindrical shape, that is circular shape. So AB is the stepped bar of diameter D1, length L1. BC is the bar of diameter D2 with length L2. CD diameter D3, length L3. And altogether, the load applied is same at the ends. It is subjected to tensile force P. Tensile force P. Right? So that is a bar, stepped bar of different cross section subjected to same load P. The load acting is same P. So if this is the condition, how to solve the problem? So maybe I have uploaded the files in Teams. Teams only files only. Added the textbook also. RK Bansal, you can refer with that, or many more problems, additional problems you can refer with that. Here is L1, L2, right? So altogether you can write, and so I already explained this diagram. So we have a stepped bar of diameter D1 for a length L1 and diameter D2 for a length L2. and diameter D3 for a length L3 for a stepped bar AB, BC, and CD. It is subjected to force P, tensile force P at the ends. So that is the explanation for this diagram, so that you can write it by yourself, right? So next, I'll just go with the derivation. So you know that since the load acting is P, it is acting at the ends. Since the load is acting at the end of the bar, the stress induced will be different at respective cross section. Since the bar is not same, if it was a straight bar, if it was a bar of something like this, of even cross section, so then the stress induced will be same at any of the cross section, right? Since the bar is not continuously same cross section, since it is varying, so if you take any section at CD or BC or AB, the stress will be different. Since the cross section is varying, the stress acting will be different. So since the stress acting is different, so we have taken L1, L2, L3 are the respective lengths at the cross section. So the stress acting at AB will be sigma 1 and stress acting at BC will be sigma 2. Stress acting at CD will be sigma 3. So, right? So you know that general expression for stress. So the stress at AB, so that is equal to sigma 1. So we'll take sigma 1 is given by what? Stress is given by what? So general expression, sigma is given by what? Force by area. So what is the force acting? Force acting is P. So area, you need to take the cross sectional area at AB. So that is with respect to diameter D1. So it will be equal to P by, so area at AB will take it as A1, P by A1. So similarly we can take, so it is similarly at cross section BC, sigma 2 is equal to P by A2. At this cross section, the force acting, it is P, it is only single force. The area is changed. It is P by A2. Similarly at another, we have, what is that? Another cross section, that is CD. At CD, sigma 3 is equal to P by A3. So these are the different stresses acting at respective cross section, right? The stress is different. Why it is different? Since the area of cross section, it is different at different section. So for this reason, stress will be right. So next. So what about strain? You know that strain expression is given by what? Since it is applied with a load, the member will be under elongation. The stress acting at AB is sigma 1, BC is sigma 2, CD is sigma 3. Similarly, the strain at AB is, we'll take it as E1, at BC is E2, at CD it is E3, right? The strain at the section, strain at AB. So that is equal to, we'll take small letter E1. So strain is given by what? Strain is given by, according to Hooke's law. It is equal to sigma by E modulus, sigma by E. So we'll consider all the bars along the steps. It is of same material. And we'll take modulus as constant. If it is different material, if AB is different and modulus changes, we'll take modulus as E1, E2, and E3. Since we'll assume it as same material, let us take modulus as E. Since modulus is a material property, if same material is there, the modulus remains same. So similarly, strain at BC, according to Hooke's law, will take So this is equal to E2. E2 is equal to sigma 2 by E. Similarly at CD E3 sigma 3 by, so it is just the same derivation as PL by AE. Delta L is equal to PL by AE. So next, so this is the strain at different section. Next, you know that, so this is by strain at different section. You know that general strain equation. General strain equation, it is given by what? General strain equation for AB at section AB, it is given by E1 is equal to delta L1 by L1. Change in length, you know, the general expression for strain, change in length to original length. The strain at AB, E1, so we'll take that as E1 is equal to change in length. At AB, it is delta L1. So length of the section AB, it is L1. So similarly at BC, it is E2. So that is equal to delta L2 by L2. At CD, E3 will take, so that is equal to delta L3 by L3, right? Delta L3 by L3. So it is just a expression what we had done in the note in the last class. So next you combine all together. Is it visible? Right. Next, total change in length. So what is this? So when the member it is subjected to force, so each section AB will undergo deformation by length delta L1, BC will undergo deformation, that is increase in length by delta L2, CD will increase by a length delta L3. So total change in length, total elongation, so it is given by delta L is equal to delta L1 plus delta L2 plus, so this is according to principle of superposition, delta L3. Total elongation, it is given by delta L1 plus L2 plus L3. So now, right? So you can call these equations, so these equations, so this as equation 1, all these three together as equation 1, and all these three can call these three equations as equation 2, and these three as equation 3, right? So from equation 1, 2, and 3, considering equation 1, 2, and 3, you know that general expression it is delta L can be given as PL by AE. So it is equal to PL1 by A1E plus PL2 by A2E plus PL3 by A3E. So from equation 1, 2, and 3, substituting, you will get the final expression as this. The general expression, you know, delta L is given by PL by AE. So at cross section 1, L is different. So L will be changing. Load P is constant. Modulus is constant. So it is nothing but PL1 by A1 E1. So this is the final expression for change in length for steppered bar with constant load. So you can take P outside and also E outside. So you will get P by E into L1 by A1 plus L2 by A2 plus L3 by A3. If it is same material, E remains constant. If at different cross section material is different, Young's modulus change irutte. In some problems, they will give some different material for different cross section. then you can take E as E1 plus E2 plus E3 only. Instead of E, it will be E1, E2 and E3 if different material is there. Right? So is there any doubt? Yeah. So it is similar to what derived with note in the last class. So it is just a same thing that is written with all the three cross sections, So it is a small derivation. Expression derive expression for change in length for a stepped bar of diameter D1, D2, D3 and length L1, L2, L3 subjected to a load of P, subjected to a tensile load P. So if that is asked question, you need to derive this, right? So just we use a general expression for stress. It is force by area, and we have written the stress for individual section AB, BC, and CD. So that is equation 1. Next, we have a by Hooke's law. By Hooke's law, we have derived. We have written equation for strain by Hooke's law. That is sigma by E for E1, E2, and E3 for all the three bars. Then we have considered general strain equation for all the different sections of the bar, and we have written the general strain equation. We call that equations as 1, 2, and 3. Then by principle of superposition, the total elongation of a bar is equal to elongation at each cross section. So the total delta L is equal to elongation at AB plus BC plus CD. So then substituting by equation 1, 2, and 3, you will get a final expression for delta L. Right? Okay. If it is finished, I will move further. So then you have a simple problem. I'll do just one simple problem on this. Then we have a next step. So this is one condition. So that is bars with different cross section and only single load. Next we have a next types of problems, different cross section bars and different loads acting at each cross section, right? That type of problems in the next classes. So if it is finished, you can take the next question, next problem. So this is fourth problem, you can take it. Fourth problem. You can take the fourth problem if it is finished. So take this fourth problem. So if you have any doubts, you can ask in this. So these are simple problems. So you have number of types of problems in module 1. So as of when module 1 finishes, you will be having so many types of problems, around 9 to 8 types of problems. In the meantime, you can mark your attendance. So I have uploaded the textbook in Teams also. You can refer with the textbook. For more number of problems, you can refer with the textbook. So maybe around first 80 pages, I think it comprises of module 1, 80 or 60 pages, first 60. Just look at the index, you will come to know which are all the in your syllabus. So note on the problem. Maybe if you understood this derivation steps, the same steps you need to solve the problem. The same step you need to solve that problem. A bar ABCD, same thing. A bar ABCD of 900 meter long. Total length of the bar is given. 900 meter long. Made up of three parts, same AB, BC, CD of length. AB is 250 mm, BC is 450 mm, CD is 250 mm respectively. AB and CD are cylindrical, and this AB and CD are cylindrical in shape, that is in cross section. So these are circular cross section, AB and CD for this particular problem. Then diameter of this AB is 25 mm, D1 is 25 mm, D3 is 15 mm, full stop. The rod BC, in between rod BC is not circular, instead it is square in section. So this rod will be square in section, so it is square, will give it as square cross section. So it is cross section is 30 by 30. So 30 by 30 square, 30 by 30 square, full stop. The rod is subjected to a pull of 26 kilonewton. So this pull is 26 kilonewton. So in the both the side, the pull of the rod is 26 kilonewton. Find the stress in 3 parts in all the rods and also the extension of, it is total elongation of the rod. No changes, it is same thing. So this diameter is how much? Rod diameter is 25. First rod, the other rod diameter 5 is 15 mm. So if I write any number, it is understood it is in mm. So I will not write any mm in front. So this diameter is given. So the length of first rod is 250. So this length is 250. L2 is 450. L3 is 250. So this is the problem statement. So this is the given problem statement. I have written all the given statement in the diagram itself, all the statement. So this is D1. D1 is so I think you have written the problem. Right? So we have, we'll take small letter. D1 is 25 mm. L1 is 250 mm. D2 illa illi. Instead of D2, we have breadth. B2 is equal to 30 and L2 is equal to the cross section. W will take it as, or B into A something, length into cross section of the next. So it is cross section, it is second bar, it is 30 by 30, it is square cross section. Then third, it is D3 will take it as, D3 is 15 mm, L3 is 250 mm. So here L2 is 450 mm. Right. So these are the given data from the problem, and load acting it is P. P is 26 into 10 to the power of 3 newtons. So these are the given statement of the problem. 26 into 10 to the power of 3 given load. So now you find out individual areas first. Before going to the problem, find out the individual area A1, A2, and what is A3. So if modulus is also given in the problem, I think modulus is 2 into 10 to the power of 5 Newton per mm square. So first you calculate the area. So I need not to do the problem. So in the same steps of derivation, you can do the problem. You need to find out the total change in length. So first you find out the individual area, and also they have asked you to find out stress in each section. So stress in each section, sigma 1 is equal to P by A1, sigma 2 stress at each section, that is at BC it is. So area at BC it is square section, 30 by 30 square. So area is 30 into 30, you calculate the area and calculate the stress at sigma 2 and calculate the stress at third cross section CD, that is sigma 3. So this is asked, and it is asked to find out the total change in length. Total change in length delta L. Same equation, use this and solve. ಮಾಡ್ಬೋದಲ್ವಾ? Any difficulties in this problem? If you have any doubts, you can ask. I will not solve any of this problem. You need to do it. I have told how to solve this. The same steps of the derivation. I have given all the data for this. So if you have any doubt, you can ask with this. What they have asked you to find is, one is these quantities, sigma 1, sigma 2, sigma 3, and total change in length, delta L. These two you need to find. And if at all it is asked to find other things, you can find other things also. If it is asked to find the strain in each section, that is sigma E1, E2, E3, then you can do it. Okay. So this can be done, right? You complete ಮಾಡ್ಕೊಬೇಕು. In the next class, I will move further with next topic. Bars with different loads with varying cross section. So ಇದರಲ್ಲಿ ಕೇಳೋದು ಇದೇ type, different cross section ಕೇಳಬಹುದು. It may be any type of cross section. ಇಲ್ಲೇ ಕೇಳಿದೀನಿ, ಒಂದು 2 cross sections are cylindrical. The area is 5d square by 4. For this center, it is square cross section. Square area is that you need to write. Okay, if it is finished, you can do this afterwards, that you just complete this problem. If it is completed, you just tell the values, or just see whether it is right or wrong. So total delta L, you will get something like 0.31. You can write the answer, but then you can compare whether it is right or wrong. 0.3148 mm delta L. So that can be done afterwards. Answer, you will get 0.3148 mm delta L. So if it is finished, you can exit. After marking the attendance, if you have done, you can exit. So if you have doubt any